Work through these. These are called block diagrams. All right, step one, let's read some instructions. Dipping strata, complete the front side and the side faces of the two diagrams. Include one strike and dip per block. All right, so we have Ordovician, we have Pennsylvanian. So the strata, that is our up section direction, right? Oldest, younger, 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 younger. So let's put a strike and dip. The smart money is that those rocks are striking that way, dipping that way, and we need to put in some lines here. You want to keep your units as constantly thick as possible. You don't have to do this, but if that's Ordovician, then that's probably Cambrian down there, Silurian, Devonian, Mississippian, Pennsylvanian. And then on the side here, when you start doing these, you got to kind of get 3D artsy, because those contacts look like they go up, but they really don't. So this one's going to hit about midway. Kind of go back and hit there, and then this guy's going to hit right about there. Something like that. Okay, that makes, here we go, one down. All right, let's go to this next one right here. All right, same game. We've got Triassic, Jurassic, K is for Cretaceous, T is for Tertiary, Q is for Quaternary. So that means the smart money is the rocks dip this way and strike that way. Let's assume that nothing is overturned. And we need to use our 3D drawing skills to come draw in this little wedge of Quaternary sitting on top, because everything's dipping at us. Then you're going to have to draw that in there. Be the base Tertiary, and then the base Cretaceous. That, as long as they're straight lines, you're good to go. And then the Triassic contact will hit down below, be somewhere down there. Triassic. So Quaternary, Quaternary, Tertiary, Cretaceous, Jurassic, Triassic. Yeah, there we go. We could label the sides. All right, part two. Let me zoom up a little so I can make sure you see everything. All right. Instruction time. Dipping strata with faults. Complete the 4 block diagrams, including contacts, fault planes, and strike it dip symbols, one on each side of the fault. If strata of a given geologic period are completely cut out at the surface, show the inferred position in the subsurface. So we have to assume everything's there. And we should have one age for each thing. Again, this is kind of conceptual, not necessarily a real-life scenario. Label the up-thrown and down-thrown sides of the block with a U and a D on the top surface. And then list out, write any specific rules. And by rules, just the why. Why were you doing this? Okay. So we've got Precambrian, Cambrian, Ordovician, Devonian, Mississippian, Pennsylvanian, and we have to draw a normal fault. And if we look at what's missing, we're missing the Silurian. So we know the fault has to be somewhere in here. Now we don't know which way it's dipping. And so when we start thinking about a normal fault, that's where you have younger strata that have moved down and are in contact with older strata. So that puts our normal fault right here. We can draw these several different ways. I'm going to kind of draw it like this. I'm going to draw the angles at a slightly higher or a slightly shallower dip than the fault. So that means that's the Devonian, and then that puts the Silurian down there. And then that would put even deeper down the Ordovician. So if I put the same dips here, more or less same dip angle, something like that, that gives me Precambrian, Cambrian, Ordovician, and then Ordovician. So there's my offset. I like to draw little arrows. Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian. It says draw dip symbols on both sides of the fault. Dip, dip. That makes this the up block, that the down block. That's my fault surface. And then I need to draw my contacts into the ground. Not great. It's fine. Okay. Vertical fault. Well, easy. Vertical fault. Now, the real trick is figuring out what's gone up and what's gone down. Okay. We've got linear units here. And you might ask, well, vertical fault doesn't really say which way it's moved. Could it be sliding side by side? Could you see this is offset, this is offset? It could be, but that is not probably what the easiest solution is here. So what I would ask myself is, what is the stratigraphic order? Pennsylvanian, Permian, Triassic, Jurassic, Cretaceous. So these rocks are dipping this way. Jurassic goes over there, so it'll kind of come out the side over here. Triassic contacts here. It's going to go down. It's going to kind of go back in there. And then I guess base Pennsylvanian may hit there. And maybe right back in there. So that'd be Pennsylvania, or Permian, Pennsylvanian, Triassic, Jurassic, Cretaceous. All right, over here we have Permian, Triassic, Jurassic. They're dipping this way, so that would go there. That would go this way. That would make that the Triassic. That would make that the Permian. And really quickly, you can see the offset now, which means this is the up block and that's the down block. Okay. And we need rules. We need to write rules, or why did we make those interpretations? So for the normal fault, I would say the hanging wall, which the hanging wall is this side. Foot wall's over here, right there. Hanging wall moved down. Foot wall up. 60-degree fault plane. You could also say there's younger rocks that have moved down and are in contact with older rocks, blah, blah, blah. All right, with the vertical fault, how do we understand that one? Well, assuming those dips, assuming dipping strata, it's also upright, not overturned. I guess we're assuming that on all these, but whatever. The block on the right is moved up. All right, so that's our up block. That's our down. Oh, I'd already labeled that. Okay, whatever. Go down to this guy right here. This is a reverse fault. I'm actually going to skip this one and move over to this guy, but it's the same as those ones up above. All right, you can actually see where the fault is on this one. So this one's maybe a little bit easier. You've got the fault. You've got the dip angles. The dip, everything should be dipping that way. Same with this, dipping that way. So you would need to draw the reverse fault on the side here. So you need to ask yourself, which way does it go? And then draw everything in. I will point this out. Notice how everything looks like it's offset at the surface, right? That and that appear offset. And so from a 100 level standpoint, you might look at that and go, oh, that's a transform fault. No, it's if strata are dipping, a reverse fault or normal fault or even thrust fault can give you those offsets that look like transform even though they are not. But in the third dimension, they are the other types of faults with dipping strata. Okay, let's look at this guy. This one's fun. All right, so we have TKJ. That's Jurassic, Cretaceous, and Tertiary. And it's a vertical fault. So let's draw it. Vertical fault. Everything dipping this way. It's not on there, but below the Jurassic be the Triassic. Okay. What about here? What's the dips here? Jurassic, Cretaceous, Tertiary, Quaternary. So we have more rocks over here. And then somewhere down beneath the Jurassic, it's going to be that Triassic, Jurassic, Cretaceous, Tertiary, Quaternary. All right, so really quickly, you can see this is the up block. That's the down block. And the question is, which end has a greater uplift? All right, so you see these contacts kind of bend back. So if you think about it, back in here, the amount of offset puts Cretaceous next to Tertiary. Those are much more similar ages. In fact, if you keep going, it would be Tertiary next to Tertiary. So there's only a little bit of offset if we keep going this direction, right? But if you go this way, it's Jurassic on Tertiary. So that's more offset, which means that the front of the block has the greater amount of offset or uplift. Okay. If you wanted to see my solution, there's my quick solution. That has to be the up block, bringing those old rocks. All this stuff dips that way. Up block, down block. All right, so let's look at these. Pennsylvanian, Mississippian, Devonian, Silurian, Ordovician. All right, so if we look at this, we see, if we were walking here, Pennsylvania, Mississippian, Devonian, Silurian, we're walking down section. These are getting older. And then when we get over here to this Ordovician, they start getting younger again. And if you look, these are folds, right? It gives away what it is. Complete the 5 diagrams, contacts on each side to show the fold axes. These fold axes are just going to be lines down the middle. That's a good place to put the fold axis down the middle. We need a couple of striking dips. And so if we want to think about that, those rocks got to dip that way. Those rocks are dipping that way, which makes this an anticline. Getching in here. Now if you look, these are really thin little units in there. In fact, I should probably sharpen my pencil, but it's fine. All right, and so once it gets over here, we need to try to honor these thin units. See how thin they are? Silurian's really thin, the Devonian's really thin. We need to honor them. So we're going to need to change the dip angle. Okay, so they didn't give me any other information, so I can take some liberties here. Ordovician is there. So that means the Cambrian's there. Yeah, well, close enough for government work. Cambrian there. All right. I need to draw on the side. Little thin baby lines. And then we're going to go there. Same there. I'd straighten those up with a straight edge, but nonetheless, those work. All right, got the fold axis. That also means the fold axis needs to come down through here. Maybe a dashed line, I guess, if I was redrawing that. Okay. All right, let's go to this guy. So Mississippian, Pennsylvanian, Permian. So that's getting into the younger rocks. They're also about the same width, so that means that they're going to be about the same dip angle. So we're just going to sketch these in kind of as easily as possible. I'm not going to make our life harder than it needs to be. Mississippi and Pennsylvania in there, so we need down below that, we need the Devonian. Maybe it on that guy. Need some dips. Strike, dip. Fold axis right down the middle. In this case, it's a syncline, so we'll put the little arrows pointing towards the middle. There we go. Clean that up a little bit, but it's good enough for demonstration purposes. All right. So this one, Triassic, is in the middle, surrounded by Permian. That means the youngest rocks are in the middle. So the youngest rocks are in the middle in a syncline. So we'll start kind of drawing our little contacts. Base Permian. That hits there, so a little bit of that edge is going to clip there, and then come on down. It's going to hit right there. So we want to keep constant thickness. Remember, this is just a schematic, so it's the best we can do. This guy's going to kind of arch down here, and then when it gets there, that one will be under there. Is that it? Gives us Permian, Pennsylvanian, Mississippian, Devonian, Devonian. All right, as far as fold axis, fold axis there, dotted line all the way through, and then for dips, rocks dip that way, rocks dip that way. Cool. This guy. All right. So got Cambrian in the middle, Ordovician, Silurian, Devonian. So this is an anticline. Oldest rocks in the middle. So we can draw a few striking dips here. But this one is going to get interesting because we have to think into the third dimension and what things look like. And so if you think about it, just think that rock is dipping that way, which means the contact is going to look something kind of like this. We're cutting through at a very weird angle. So that would be somewhere down in here. That makes that Silurian, Ordovician, and then the Cambrian contact's going to hit down in there. And if you look through here, what this is going to look like, that contact will hit there. You can think about the fold as kind of sitting through. You're cutting through the fold, so we need that base contact there. Doing. All right, so if you're wondering where this contact is, it would actually go up into the air and over. Okay, so we don't actually need to draw it. Just because it's on the edge, those rocks are kind of domed up and over, so we're not going to actually see that. What you're going to see is this lower one, Devonian, Mississippian. See this contact kind of come up, go down. Go that way. Go that way. So that would be your Devonian there. Silurian. Oof. I love that. So your Devonian's there. Your Silurian is going to kind of arch up underneath it a little bit. Same here. This will arch up underneath that. Okay, so it still looks like a bit of an arch back in there. You can see that's the fold. All right, this is my personal favorite of all of them. This wild and crazy thing. So you don't really get overwhelmed with it. Just look, Pennsylvania, Mississippi, and Devonian. So you've got the youngest rocks in the middle, which means that's the syncline. So you need to connect those guys up. But if you ask yourself, well, this is Mississippian, Devonian, Mississippian, so that's an anticline. So the little contact will go up in the air, but we don't have it. And then the Mississippian contact goes back down. It's going to kind of wrap around there. You get something like that. And then we got more rocks down there too, Devonian, Silurian. So we got Silurian rocks. So we'll sketch those in best we can. Trying to maintain our constant thickness. The Devonian, and then somewhere down here, I'll just make my life easier. Cool. All right. All of them.